All right. See you later. Thanks for stopping by. All right. So questions off of our homework. What did we see that we can I can help you with? This is on. It just says title at the top right: Graphing and TI Calculator. Of course, we are choosing to use Desmos more than the graphing calculator. Agree? Is there any of those that I could help you with? Help you answer? Feel okay about it? Yay? It's because the room technically really costs $27 because you included the $2 tip. And then you each got $1 back, so 28, 29, 30. So I didn't do order of operations correctly.
I know, but I'm just still trying to like think through it. Confused.
So yeah, just kind of fun. All right, no questions? We're happy? Satisfied? All right, flip to the next page. It says graphing review number 1. Okay, and again, we're going to be using Desmos. We're going to continue our adventures with Desmos. Oh, there it is. Couldn't find my little pen. All right, so let's reduce this. So let's take a look at, and not all of this book is like this, just for these preliminary chapters, we're just kind of reviewing some stuff. So let's talk about problem number 1. Please write on your worksheet and your workbook anything that I write down. And let's jump to Desmos. Okay, and you can follow along with Desmos on your phones if you'd like as well. So I would like to go to problem, let's see, 1, 2. Let's go to problem number 3. Problem number 3. So we have y equals, and then under my keypad I have to find the absolute value. Absolute value of x plus 2. Move the arrow out to continue the absolute value, and then minus 3. Okay. Let's darken this a smidge. Like that. Okay, so you're seeing pretty much the whole graph there. There's not a whole lot that's going to happen as I go to the right and up or to the left and up. But talk to me about things that you notice about the graph. Just use your words. It doesn't have to be some fancy math jargon. Yes? When it hits -3, it bounces back up. I like that. Those are good words. Yes? Oh, it shifted over to the left. Okay, so where the bouncing point is happens to be to the left because we think, well, let me put just a regular absolute value graph up there. Y equals absolute, oops, not a capital Y, let's go with lowercase y. Y equals absolute value of x. So the blue is we're going to call our parent function. So I like your shifting left and I like our shifting down. Those are all very legitimate comments. What else do you notice about the red versus the blue? Oh, the slopes appear to be the same of each line. I like that. That seems good. They seem like they're parallel lines to as you go to the right or go to the left. I like that. Okay. What else in your words can we say about the red. Yes. Okay. Okay. So hang on, let me reduce this and I'll pull this. I can pull that. So are those basically the same point? That's like a turning point of the graph. Can we say turning point? Would that be an okay term? Meaning it changes directions. Okay, so that definitely shows us the left shift and it shows us the down shift. Let's talk about the x-axis that's in there. What can you tell me about the x-axis for the relationship to the blue graph versus the red graph?
The red graph crosses it
The red graph crosses it how many times?
twice.
Twice. Okay, so the red graph crosses it twice. So it looks like it crosses here and it crosses here. And we know those are crossing points because our y component is 0. So the blue graph has one solution. Can I say that term? The blue graph has one solution. The solution is 0. The red graph has two solutions. The red graph's two solutions are -5 and +1. So notice when I'm saying solutions, I'm referring to the x part of the coin. Does that make sense? Can I say that the red graph is negative in the y direction between -5 and 1? When I say negative, that means it's below the x-axis. Are those 2 points? Is it in between those two? Are they underneath the x-axis? Okay, so that means that my equation, my red equation, it has two solutions. Between those two solutions, if I plugged in any value between -5 and +1 in the x direction, that my result, my output, my range would be a negative number. Is that okay? So that's kind of that's some characteristics that you might want to be thinking about. And your words are totally appropriate to use. I'm not going to hold you to saying, no, you have to say the domain, blah, 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 and the range. No. Let's not play that game. Okay? So that takes us up to, if we take a look at, say, number 7. Now, number 7, we have an inequality there. I'm going to use y equals x squared plus 3x minus 10. Okay, and I'll kind of zoom that like that. Okay, so do you feel comfortable that that very bottom point is a turning point? It changed from a direction of going downward, and it was at the very instant at -1.5, -12.25, that it was not going down, it was now going to start going up. But at that very instant, it's like staying straight. So think about this as like, you ever, we call them whoop-de-doos when we're driving. Is there any road that you know about that if you go fast enough that your belly goes, you know the road I'm talking about? Okay, where your belly goes woo is at that exact instant where it goes from going down to going up, or going up to going down. Okay, so your body knows math. Your tummy goes woo, and we get those little butterflies. Okay, so basically this graph, as I come along, is heading down until I get to -1.5 in the x direction, and then it's horizontal, and then it starts heading back up. Okay, now this particular problem on number 7 said we want to know where, so they have it written on number 7 on our notes as x squared plus 3x minus 10 is less than or equal to 0. So less than or equal to 0 means it's below the x-axis. Do you feel comfortable that where my hand is and down is all below the x-axis? So from here down. So if I did a piece of paper like this, so right there, it's exactly at 0, and then as I move down, it it is a negative y value. So how would you describe to me, if I were to say, hey, where can you guarantee by looking at this graph, by telling me numerical values, where it is below the x-axis, or less than or equal to 0? Go ahead. Real close. -5, I totally agree with. What's the other point on the right? 2. So -5 to 2. Okay? So that particular graph, let's get off Desmos for a second. -5 to 2. So basically, this graph that if I pick some region here, if I looked at the x values, if I picked an x value from -5 to 2, if I don't include the endpoints, if I picked this one or this one or this one or this one, and I'm going whole numbers, but of course the fractions and decimals exist in between. If I picked any of those circled points, these would result in a negative y value. So that means it's below the x-axis. Now, of course, the problem that they originally gave us was this. Okay? So this little equal sign here means I'm going to include those points. So how you're going to label this is you're going to say, as far as the domain goes, so where the domain is less than, let's not do that. Domain results in range being negative or 0, we would say square bracket -5 to square bracket 2. The square brackets mean that I'm including those endpoints. If it just had if this was not, if this didn't have the equal sign to it, if it just was less than, I would put parentheses or soft brackets on both of those. But because I have the little equal sign, if I pick anywhere from -5 to +2 as an x value and I plug it in, I'm either going to get an answer of 0 or an answer that's negative because it's below the x-axis. So notice on my really bad drawn picture, I didn't draw the picture itself in. I just looked on a number line. And what if I took that number line and I put a plus here, a negative here, and a plus here? What would the plus minus plus mean to you as far as the graph? Being I only drew a one-dimensional graph up there, a length. I'm not referring to the two-dimensional graph. So what does that plus minus plus mean to you as far as what our picture would look like if we didn't see it before? Above and below the x-axis. Yeah. So the positive over here refers to, hey, we're above the x-axis. The negative here refers, this is below the x-axis. The positive right here refers that we're above the x-axis. We have critical values, which are exactly where it crosses the x-axis. But that's just awesome terminology that we could be using. All right, I'm going to flip to the back side, and we're going to take a look at problem number 9. So problem number 9 says this. So we have the square root of x minus 3. Now, does everyone feel comfortable that this is the same as saying y? That means the same thing. Okay, so this is y equals that. I don't have to have function at x. But they want us to know what the domain would be. Okay, the domain are the x values that work for us to plug in that don't give us, bless you, a negative under our square root sign. So a lot of times the picture of it is going to help us out. So I'm not going to use f of x. I'm going to use y equals. Y equals, find my square root. and I have x minus 3. So friends, right there, you're seeing the entire graph. There's nothing that takes place way in the negative direction. As I continue in the positive direction in the x direction, the graph is going to continue to climb. Okay, but that's what a square root function would look like. So if I click that point, that gives me my exact solution. Friends, how do I know that's a solution? What sticks out when I have the point highlighted that says that's a solution? Yes? It's on the x-axis. You know it's on the x-axis because what part is 0? The y value is 0. Good. Okay? So we're building in some terminology. Desmos becomes a really valuable friend for us because it does a lot of things. So if I wanted to talk about our domain. So friends, does this point exist on our graph as part of our graph? You agree? Cool. So my domain is going to go from 3, and we're talking about the x direction. So I'm just worried about if I plug values in. So if I got over here to 10, there's a y value. If I got over here to 20, there's a y value. Does that make sense when I say that? Okay, so those values do indeed exist. So my domain of this function is going to go from square bracket 3 to infinity. Infinity always has a soft bracket or a parenthesis. Okay? It's a square bracket because we could see where the graph started. It started exactly at that point. We include that point. That point didn't create something that's undefined because I could do the square root of 0. The square root of 0 is just 0. Okay? Okay. Number 11. I'm not going to do it, but I will just tell you, you should do it this way. Do it on Desmos. Okay? And if we do that, we might be able to figure out some sort of domain that takes place. Okay? If this graph doesn't have any gaps or doesn't start or stop at certain locations, things are going to happen for us. Okay, so you talk about what we could plug in that would give us an answer out. As I look at this, I don't think there's a value that if I plug in for any of my x's, that's not going to work. But just for the heck of it, let's just work it because I want to see if I can get my information. So I got y equals x squared minus 3x. Okay, so it gives me a parabola. My other side, I have y equals the negative absolute value of x minus 2 plus 3. Okay, so let's move this down. Let's move this over. Let's zoom in at those main characteristics. So okay, those 2 points are the solution to this problem if we had y components, but we're not using y components unless we graphed it. But we have these 2 different graphs. So if I look at the x value only, I can find the intersection at negative 2.36. I'm only using the x value. And I have an intersection at 3.449. Okay? So if you just look at the x values only. All right. I think I've done enough damage. Y'all are still trying to figure out where that last dollar went. So I would like for you, for tomorrow, work on the graphing review number 1. I'll check it off tomorrow. If you weren't able to complete the homework from yesterday, if you get it complete tomorrow, let me know, and I'm happy to put it in the grade book for you. Okay? There isn't penalty for late homeworks. There's not penalty if you were absent for a test or quiz. I mean, what I would just ask, if you missed a test or quiz, don't be like some of the freshmen I have in CP Algebra 1 who might have missed. I had kids that missed something like September 3rd, and here we're in the middle of December saying, hey, you still owe me this quiz. That's not good practice. So I'd say if you ever do miss a test or a quiz that I have given physically in class, come see me on one of your off periods. It does not matter if I have a class in here or not to get it made up, okay? And then always make sure you have your phone. On your phone, make sure you have Desmos, because Desmos is going to be used over and over and over. I want us to feel really good about Desmos. I'm not too worried about the graphing calculator. Yes, you're certainly welcome to use the graphing calculator if you have one. But I'm going to focus more on Desmos because a couple of reasons. One, you'll always have your phone with you. Two, Desmos is free, so I'm not asking you to go drop, $100 on a graphing calculator that will sit in your bag, and you'll be in college and you'll pull it out at some point in college, you turn it on, going, oh, the batteries are dead. So that's what I got. Did I do okay? Save.